Good afternoon. Today I will lecture on the residue of any complex function. Let we have a simple closed contour C and a function fz is analytic inside and on the closed contour C. Then according Cauchy integral theorem, always the integration of the function equal to 0 if there is no any singular point inside this contour C. That is, function is analytic inside and on this contour C. In this case, always the integration is 0, but if a function fz has one or more than one singular point inside C, suppose that inside this curve, inside this contour C, we have more than one singular point. Let we have three singular point S1, S2 and S3 and S1, S2 and S3 are isolated singular point. Then the integration of fz dz may or may not equal to 0. In this case, each of these singular point inside this contour C contributes to the value of complex integration. It means all the singular point inside this curve C can change the value of the complex integration. This type contribution of the singular point inside this contour C is known as residue. It means residue is just a contribution of the singular point. For example, let we have a function fz equal to 1 plus z square upon z minus 1 to the power 2, z plus 2. In this function we have two singular point and two isolated singular point at z equal to 1 and z equal to minus 2. That is pole. Both are pole. So we can calculate the residue of this function at the point z equal to minus 2 and z equal to 1. And after calculating the residue, we can simply find out the integration of the function. Basically, the residue applies for evaluating the complex integration. Sometimes we can also use a residue for evaluating the real integration. That's all. This is the definition of residue, and in next lecture we will learn about how can we calculate the residue and how can we solve the integration using residue theorem. Thank you.